Hello, colleagues. My name is Spivakov. As mentioned, I am C3D Converter Development Team Leader. Let me introduce the updates which happened to the product this year. Today, I'll start from the role C3D Converter plays in the toolkit. Then, let's discuss how C3D goes to products and products to ecosystems. After that, we will see how it could work with the Parasolid ecosystem. And we will finish with the improvements and our plans in future. If you have not worked with C3D Toolkit yet, a couple of words for you about the converter component. There are two main cases of C3D converter usage. The first one is to provide all other components, for instance modeler and vision, with data from outside. We call that input. The second is to give the designed models to applications which deal with 3D printing, simulations, or something else far from modeling. We call that export. The subject the converter deals is shape of models in all available representations, assembly structure, attributes, and manufacturing information. To read and write all that, different exchange formats are supported, both open such as JT or designed by other kernel vendors such as ACSAT. In addition to that, additional exchange protocol for plugins was designed. Now let's have a look how C3D-based applications evolve. This case seems to be typical for us. Usually, application developers start from in-house or open-source math solutions. The primary data representation comes from subject area. Shape is calculated. Gradually, it turns out that commercial solutions fit better. And here there is a choice between us and other vendors. Regardless of that, the geometric representation becomes subject of the selected engine. In case of C3D, the software and file become C3D-based. Let's have a look at further stage of life cycle. What's happening to end users. Modern industrial companies already have information system where a variety of processes running, from design and simulation to personal education and maintenance. To provide all them, software from different vendors work. C3D-based solutions also take their roles in these systems. We call this scenario multicad. And here the key functionality of software is ability for data exchange. Converter component plays the key role here. This year we faced a challenge how to provide work of Compass 3D, C3D-based CAD in Siemens NX ecosystem. The data exchange system had to meet the following major requirements: read JT format, write JT format, and read NX PIT format. C3D Converter supports JT format since 2019 year. What could go wrong since that? First, ISO updates specification every 5 years. We started from the first release, now the third one is coming. Second, Siemens supports its own branch of JT format. Third, different applications have different expectations from data written into files, and that also should be taken into account. C3D Converter supports reading meshes from JT as long as supports this format. This time we could not extract shape of one part. Gradually, step by step, we managed to get first shape of part and then the normals. As a boundary representation, Parasolid XB is the most frequent format in JT files. This format regularly updates, and for compatibility, schema could be embedded into file's body. Originally, C3D did not embed any schemas and had no troubles, but in context of multicad, it turned out to be critical. So, writing embedded schemas was implemented. By the way, the same XB files written by C3D were read correctly. As soon as the issues with Parasolid have gone, new ones related to MB structures appeared. The models, which looked well in a viewer, broke in a CAD application. All spatial transformations were lost. Obviously, this application processes the scene graph in different ways. To describe the scene graph, many entities present in JT: group, metadata, range, and other. We improved our export procedure so that models exported from C3D looked equally in all available applications. And last but not the least is reading CAD formats. It is the most challenging requirement. 2 years ago, we presented our plugin system and showed the models inputted from NX and SolidWorks files using third-party toolkits. Now we have our own solution for that. Here are some parts and assemblies from NX. PMI is also presented here. And here are some parts and assemblies, also with PMI we managed to read from SolidWorks. Mentioned above doesn't mean we were focused only on multicad project. We didn't stop our work on quality of input and export. Here, the first figure is the same solid, which was exported into IGES and imported back. The tessellation shouldn't depend on tessellation settings as dramatically as shown here. Key problem was here is a very narrow phase, which was comparable with metric tolerance. This case is bad for numerical algorithms. The second figure shows how a new type of blended edge is processed. This blended edge came from Parasolid. And the last figure is the same model. We improved input from assemblies, which part were designed in different length units. Finally, export into 3MF format was implemented. This format is used for 3D printing. We used to support only STL formats for that. 3MF format is more sophisticated and looking much more promising. Our plans in the future are for following. As for plugins, we are going to support IFC exchange format and get able to read Creo files. Also, we won't stop our routine work on quality improvement. In addition, reading 3MF and subformat are planned. Thank you for your attention. Feel free to ask your questions.